Hello everyone. Today we are solving LeetCode problem number 1975 maximums matrix sum. So you are given an n cross n integer matrix. You can do the following operation any number of times. Choose any two adjacent element of the matrix and multiply each of them by -1. Two elements are considered adjacent if and only if they share a border. So we all know what exactly is an adjacent element, right? Your goal is to maximize the summation of matrix elements, return the maximum sum of the matrix elements using operation mentioned above. So based on this question and by looking at the first example, I'm thinking that this matrix might might have negative numbers included within it. So let us confirm this by checking the constraint. So if you check the constraint here, we have the matrix element lies between -10 power 5 to +10 power 5. So the element can be negative and positive. So it is because of this they have given this condition to change the negative number to positive by multiplying -1 for two adjacent elements at a time. And when I look into this problem to find the maximum sum of this matrix, what exactly I'm thinking is about using this absolute function, which will give the absolute value of the particular number. So let me write down the ask or requirement. Maximum sum by following condition. So my thought that is to use absolute value function, but we cannot go ahead and right away use this because of the constraint mentioned here. That is, we can choose any two elements and we can multiply that by 1. We cannot go ahead and use absolute value function for every element and return the maximum. That is not possible because of the given condition. So this will not be possible. But let us check this with running an example. Yeah, so before that, let us understand this constraint or condition better. So the first condition you could see is we have to choose adjacent elements of a matrix. So two elements which is adjacent can be left to right, or it can be top to down. The diagonal elements cannot be considered the adjacent. So this is not adjacent. The diagonal ones are not adjacent. So only the top down and my bad and the left to right, we can consider those elements as adjacent. So we can multiply them with -1 at a time. This is the first observation based on the condition, and you can do the following operation any number of times. So any number of times we can do this following multiply one operation any number of time. So with keeping all this in mind, like now we have a better understanding of the problem, right? So let us run through the first example. So if you see this first example, you are given a matrix 2 cross 2 matrix with 1 -1 -1 and 1. So this is the given matrix, and what exactly they are doing is they are in the first operation they are multiplying -1 for this particular adjacent element. So it becomes -1 1 and -1 and 1. So this is the output, and you could clearly see that this particular this two adjacent elements are minus 1, and multiplying by minus 1, that is by performing the next operation, you will be getting all positive matrix, right? And the output, the sum is 4, so this is the output they have given. So what are the observation from here? Given you have two negative numbers, right, and those negative numbers are found opposite to each other, meaning they are not adjacent in the first look, and yeah, so these two are the observation from this first example. So let us consider the second example from the sum for further more understanding. So we are given the matrix, it's a 3 cross 3 matrix. Let me write it down in my notepad. Right, so this becomes, we are finding, I mean, we are making this, converting this per two adjacent elements, multiplying by minus 1 and making them positive. So 1 2 3, negative 1 2 3 2 3 1. So the sum is 3 plus 3 plus 3 9 plus 6 plus 2 minus 1, so which will result in 15 17 and 16. So this is the output which we are getting. And what are the observation? So from this observation we could see there are three negatives, and so finally what are we doing? There are three negatives, and eventually the three negatives, two gets removed because of the adjacent rule, multiplying negative 1 with the adjacent elements. Two we are removing, but what two elements exactly are we removing? We are keeping, I mean, we are multiplying the maximum of these two, the absolute value of the element which has the maximum absolute value of the number, which those numbers we are considering to multiply with negative 1, and the minimum of all the three numbers, that is what we are having them untouched. So we are finding minimum number among all from the matrix assign negative, and 3 negative gets dissolved to 1 negative. And same observation here, the two negatives becomes 0 negatives. So from this observation we can come to a conclusion that if negatives are the number of negatives, we can have it as number of negatives is even, it will become 0 negative at the end and find complete sum using absolute function, right? And if the number of negative is odd, then you have to, this will eventually get reduced to one negative. So you have to find minimum among all elements in matrix, right? And subtract this from the sum of all elements. And one thing you have to observe is this is not exactly right, because for some we are considering the absolute value, right? So we can consider this example only. So the absolute value of this particular example 2 matrix is 9 plus 6 plus 3, which is 15 18, right? And we have one negative here, and we are hence because of that we are getting 16 as the maximum sum. Why is that? Because if you watch carefully, we have all three positives, so which is 9, and all two positives, which is 6, and we have 2 1 as positive, which is 2, and 1 as negative. So we have to sum all this up, right? So which is -1. So because of this we are getting 16. So if you carefully see that, like, you can come to a conclusion here that you have to find the smallest minimum element, and you have to multiply minimum element by 2, and then subtract this from the total sum, right? So these two are the main observation, and these two are the main condition which we are following to code this up. So let us now go ahead and code it. So we need a result to return, and we have to count the negative count, because on the observation we are using negative count to process it, right? So neg count, let that be 0 first, and we have to set a minimum value so that we could find the minimum value from the matrix. So that should be positive infinity, so that we have to have a very huge number just to compare it with other number, right? So because of that, I'm sorry, yeah, float, this should be yeah. So now we have defined whatever we want to process this, and we have to start processing it by iterating through the matrix. So for nums, we are fetching the first row completely in, and we this has the row array or row list. So, and now for val in matrix, I'm sorry, val in nums. So this val will be this is anyway, like, without using this range function, I'm just fetching the elements just to process, because we just need the elements, not the index, right? So now we have to find the sum. So is equal to, we have to find absolute value for finding the total sum value. And now we have to count the negative number. So if val is less than 0, you have to increment negative count by 1, and also you have to find the minimum value, right? So minimum of value with the absolute value. Yeah, we have to find the absolute value, and then we have to find the minimum value, because if there is some negative numbers we are encountering it directly, that will be getting updated as the minimum value. So we cannot use that, because if the negative the for example, if it is the higher number like -11 or -12, so if we convert that into positive, it will be higher, but if it in negative, in case of negative, that will be the lowest, right? So we cannot have the minimum element as that. So yeah, so we have done everything here. We are getting out of the loop, and now we have to check if the negative count, based on that we can process it. So we are anyway returning it. If the negative count is even, we are returning the complete result, because we are just processing it by the absolute value of every element and sum it up and then return it. In case of odd, this is different, right? So because of that, if negative count modulo 2 equal to 1, then so as we discuss here, we have to multiply this with 2, because I have explained that in the example while drawing the dry run, or explaining with the example. So this should be multiplied with the minimum number. So minimum value. So the time complexity here will be, since we are using the standard iteration for the matrix, this will be order of n square, and there is no additional space complexity space we are using, so it will be order of 1. So big O of n square and CSC big O of 1. So hopefully this should work. Oh, oops. Yeah, and it is efficient solution. Thank you.